All right, let's take a look at this second puzzle that we have. Um, Here, it's kind of the flavor of the days before um, calculators and stuff. Even at my age, although I had calculators in high school, most of the textbooks still had what they referred to as trig tables in the back of the textbook, as well as log tables that you given an angle that it was usually either to 3 or 4 decimals and stuff, and even some of the bigger tables had, you could look up angle measures maybe every tenth of a degree, a 0.1, a 0.2, a 0.3, depending on how big the book was and how expensive it was to how many decimals you wanted on your angles. So here it's just by it looks like it's counting by fives, and we would just do like a linear interpolation if we needed a value that was between 0 and 5 back in the old days. So with the sine of 70 degrees, all we have to do here is look in this first column and find the 70 degrees, and these other 3 decimals here. See that the ratio, the sine, we know the sine with respect to a right triangle is the length of the opposite leg divided by the length of the hypotenuse. They've done that division for you, and rather than giving it to you in the form of a fraction, that this table is just giving it to you in the form of a decimal number to 3 places, and there's our answer for the sine of 70 degrees. So on all of these, we're just simply going to read off values from the table. So the cosine of 25 degrees, it's a multiple of divisible by 5. It's in my table. Here's 25. Cosine is the second column. So the ratio of the adjacent leg divided by the hypotenuse, although that's a fraction, the table is giving me that fraction in the form of a decimal. And where'd it go? 0.906. The tangent of 30 degrees, we come over here and we have 0.577. The sine of 5 degrees, up here the first column, 0.087. The cosine of 60 degrees, find 60 degrees and come over to the second column, 0.5. The tangent of 75 degrees, find 75 degrees, come over here, that's, I'm seeing 3.732 if I'm reading off that. That is one thing. A lot of times, you would see people that would have a little, 6-inch ruler or a 4-inch ruler and just run it along there to make sure that they are on the same row when they're reading values. It was awful easy to accidentally read the wrong value from a table. All right, so let's take a look at this next one here. This time they are not giving us the trig function. They're just giving us the angle measure, and they're saying you have to find this ratio A divided by C. Well, without this picture, how would I know if A over C represents a sine, cosine, tangent, secant, cosecant, cotangent? I wouldn't know. But when I look and see that the side A over C, then A over C, if with respect to angle A, is the opposite leg of the hypotenuse. So I'm going to use the table and take the sine of 40 degrees, and the sine of 40 degrees is equal to A over C, and they're going to give me A over C as a decimal form, not as a fraction. So if I come in and read 40 degrees and I come over and read for the sine, 0.643 is our answer for this one. And we just continue in the same fashion. There we have the measure of angle A. Now this time, look at what we have. They're asking us to find the measure of angle A, and they're giving us this ratio of A over C. With respect to angle A divided by C is the opposite leg of the hypotenuse, so it's the sine of angle A that is equal to A over C. And they are telling me that A over C in decimal form is 0.342. So I need to look in this first column for 0.342, or as close as I can find to it, and here it is. So the measure of angle A that they want is 20 degrees. So see, this is the idea of the inverse. If they give us an angle, we give them the ratio. That's normally how we write these trig functions. But if we go the other way, if they give us a ratio as the input, and if the output of the function is the angle measure, that's the inverse sign. So we will see that A is equal to the inverse sign of this A over C, and that is the notation. Remember that -1 is an inverse notation. They're not emphasizing the inverse notation here, but we are using the idea of an inverse on this problem with this table. All right, so we're back to that they're giving us an input of an angle measure, and the output is the trig ratio in the form of a decimal. Angle A is here in my picture. A divided by C is again the sine. So the sine of 55 degrees is equal to the ratio A over C. We know that the sine of 55 degrees from the table is 0.819, and hey, that's our answer. That's what this A over C is equal to, is the 0.819. A over C, again, with respect to angle A, is the sine. So the sine of angle A is the opposite leg over the hypotenuse. But this time, again, they're giving me the ratio in the form of a decimal. And they're asking me to read the table, kind of in reverse, the inverse. And so now the input into my function is 0.906. So like I say, you'll begin to see this notation that the input into this inverse sine function is this ratio, and here it's in decimal form, and the output of this function is angle A. So if I come into this first column and look for 0.906, I'm getting that that's 65 degrees. The measure of angle A is 30 degrees. Now B over C is the adjacent leg of the hypotenuse. So now the cosine of 30 degrees is this ratio B over C. So if I come in here and read off from the cosine of 30 degrees, I get 0.5. So this ratio of B over C is 0.5. They're asking me for an angle measure, so I'm coming into the body of the table and reading the angle measure. It's the idea of an inverse. With respect to angle A, B and C are the cosine, so I have the cosine of angle A is B over C. So using inverse notation, they're telling me in decimal form that this ratio of B over C is 0.643. They want me to tell them the angle measure in degrees from this table. If I use this middle column here, and I come and I look for value closest that I can find to 0.643, and here I found it exactly, and that's 50 degrees. And so there's my answer. Measure of angle A is 65 degrees. A over B is the opposite leg over the adjacent leg, that's the tangent. So the trig ratio with respect to this triangle, the tangent of angle A that we know now to be 65 degrees, A over B is where's 65 degrees at here, and the tangent is this last column, 2.145. So this, instead of in fraction form, we're giving it to them in decimal form. With respect to angle A and B are as the opposite leg over the adjacent leg. So the tangent of angle A is the ratio A over B. They give me that ratio. So to solve for angle A, the idea is the inverse tangent, and this ratio in decimal form is 1.428. So the input into this function is the ratio, and I look and I try to find it, and the output is this angle measure at 55 degrees. The measure of angle A is 55 degrees. Angle B and A over C. A over C is the cosine. The cosine of angle B with respect to this picture is the adjacent leg divided by the hypotenuse, A over C. And it's giving me that angle B is the cosine. It's giving me angle B is 80 degrees. So I can use the table to give you this ratio of A divided by C, but not in fraction form, but in decimal form. So I find 80 degrees, and the cosine's the middle value here, 0.174. So with respect to angle B, A over C is the cosine. So I have the cosine of B is A over C. I could rewrite this equation as this angle B is the inverse cosine of this ratio, because that's what it wants, is this angle B. So I will use the table and figure out what the inverse cosine of 0.985 is. Come in for the cosine column, look for 0.985, 10 degrees. All right. They want a ratio. They're giving me 45 degrees. Angle B, B over A is the tangent. So the tangent of angle B is the opposite leg divided by the adjacent leg. They're telling me that the measure of angle B is 45 degrees, and they want me to figure out what the ratio of B divided by A is. I come in at 45 degrees, I read off from the tangent column, and that's 1. So with respect to this right triangle, they want me to find the measure of angle B. They give me the ratio of B divided by A. With respect to angle B, that's the tangent of angle B. So the tangent of angle B is B over A. But they don't want me to solve. This is solved for in B over A. They want it solved for in terms of what B is. What is angle B? Well, it's the inverse tangent of the ratio. And this ratio B over A is given to me as 11.43. So if I come to this right column here where it's tangent and find as close as I can to 11.43, I can read off the angle measure. 11.43 down here at the bottom is very close to 85 degrees. The angle B and B over C with respect to angle B is the opposite leg of the hypotenuse. That's the sine. The sine of angle B is equal to B over C. So it gives me B and it asks for B over C. It provides the angle measure of 50 degrees, and it says, well, if angle B is 50 degrees, what is this ratio? And I can use the table to give you that ratio in the form of a decimal. So I can come up to 50 degrees, and the sine is the first column. So if you take B divided by C, you will get 0.766. With respect to angle B, B over C is the cosine. So I have the cosine of angle B is equal to B over C. But they want us to solve this for angle B. They want B by itself. So I have to take the inverse of this ratio. They give me the ratio. They tell me that B divided by C in decimal form is 0.259. To tell them what angle B is for an input of this ratio, I come into my table, I read off as close as I can, there it is, 0.259, 75 degrees. It wants the measure of an angle, so that's an inverse. And it's telling me what the sine of angle A is. So let's try to figure this out. The sine of angle A is the opposite leg over the hypotenuse, A over C. And so they're telling us that this ratio of A divided by C is 0.866. So I know I can figure out angle A from this because I can use my table. A over C is equal to this 0.866. So if I look for 0.866 here, then I know that angle A is 60 degrees. Now, I know that angle A and angle B are complementary angles because this is a right triangle. So I know that if I take 90 minus 60, that the angle that they want, B, is 30 degrees. And that was the last one. Hope that helps. Talk to you later.